Hi guys, today we are going to talk about classes, functions, constructors and objects. So let's begin. As we already know, we can create object like this, like A, and here could be some B equal 5. Yeah, basic object. And also, as we know, we can inherit it. Inherit all its properties, like var, let's say C equal object create, and here we can reuse its properties like console log C B, and we will have 5. Okay, we know it. It's easy, and in real life, let's make it example from the real life. Let's say we have car, and car can have some engine, for example. It can be something about 3.0, and also it can have some methods like run. It can be run, right? It could be function which console log run. So simple. Also we can make it to stop, and now our car can stop. Easy. And now I can inherit it and reuse it. So for example, I have car and it has some properties which all cars will have. And now I want to create some Toyota which have some specific behavior, and also Toyota must have all properties from this car. So I can reuse code that I already create. It can be like this: Toyota equal object create car. So simple. And now I can reuse my code like Toyota, and let's run. Oh, sorry, Toyota. Here we need to add some comma. Yeah, so our Toyota now can run. Easy. So this is inheritance. This is the way how object-oriented programming works. We can inherit some objects and reuse code. It's really cool. Okay, let's create more interesting example. Let's create function function. We already spoke about functions, and now you know what is it. So we can go further. So we have function car, and we can make this well, as you know, as I already told you, function is objects too. So this is object, and I can reuse it also as objects before, like here, like this car. I can reuse it, and I can also have it some engine. It can be equal 3.0, and also I can add some methods here like car prototype. Well, of course, if I want to add some methods to my car, I need to do it through prototype. So I can make it like car prototype equal, and here will be objects with all methods. Let's make it like this, and here I can copy my run function and stop function. So I have almost the same object which is here. So it has engine and it can run and stop, as you know. And what interesting that this object can be used as constructor. This function can be used as constructor to create object. And for example, I can make it like Toyota 2 equal new car. So what happened here? Actually, I create object when I use functions with new keyword. This function use as constructor, and constructor, this is functions which creates objects. So everything what happened here was made to create new object, and this object has engine which is equal to 3.0. So my Toyota 2 is a new car, so this is new object which has engine and it can run and stop. Cool, right? So this is function which is object. Something like this. And now I can set Toyota to run, and it will run, as you see. Easy. Also it has engine. Well, it's 3, as you see. Everything works cool. So that's the way how we usually create objects in JavaScript, because it's more object oriented, because we can use constructors. And well, when you create just usual object like this, yeah, this object don't have constructor and you can construct it. But when you use it as car, well, yeah, it use constructor. So this is really cool when you can create object. A little bit later I will show you why. Just a minute. But before, I want to show you that you also can run this function as just a car. That's all. You can run. But it will be just a function which will create some variable, and after end of this after end of this function, this variable will be deleted, and that's all. So that's the main difference. When we call it as a function, it just do some job and forget everything. But if you run it as with keyword new, it will be an object. Yeah. So let's go further. Also, I can show you that our Toyota is instance of car. As you see, it's true. So if you have some object and you want to make sure that this is instance of car, you can check it like this. Okay. Also, each function, for example, our car. Okay, let's make it like this. Var f equal function, and it has prototype. Var p equal f prototype, and prototype has constructor. Var c equal p const structure, and console log c equal f. So this function is constructor of itself, something like this. So it has prototype, prototype lead constructor, and this function is constructor of itself. Well, it should be, yes, because it's creating itself. And also, let's talk a little bit about object-oriented programming. So this car, it can be constructed, and this car is object, but well, also we can call it class. Why so? As you know, in object-oriented programming, we usually make object which represents real object from real world. And for example, we can have table, and table can be described as color, length, width, and etc. So when we describe some object, this is class. So class, this is description of some object. For example, here we describe object car, and we said it has engine. So this is an class description of an object. But when we run like new car, it takes this description and create object in memory. And this is object, and this is class. If we talk about how to call everything, so this function is class, and this is paradigm come from object-oriented programming. This is function, it's class, and also it's constructor. So this constructor create from this class real object when we use new. I hope it's clear. Okay, let's go further. As you see here, this function each constructor of itself. But what if I create some object with it? Let's say var o equal new f. I create object, and this object has constructor. And what's interesting, it's not f. Oh yes, sorry, it's f. I thought about something else. Yes, it's f, as you see. And now about constructors. So now as we see, function has prototype, prototype has constructor. What if I would like to override this constructor? Like function console log new c. So new constructor and here let's make it console log old constructor. Okay, let's save it. And we shall run it. Some exception. Here I forgot. Make it like this. Yeah. Yeah. So now we're cool, and let's see our console. And as you see, old runs, but new don't. So if we try to add constructor like this, it would be not some property, it would be just an constructor. So as you see, we tried to add it to prototype, like here to p, add new constructor, but it doesn't work. so original constructor will be the same. Also, I can add, after I create my object, I can add new properties. For example, I created this Toyota, and now I can write like car prototype, let's say brake equal function console log brake and Toyota 2 brake. And as you see, my Toyota now can brake. So the main idea, even after constructing, I can add new properties through prototype, using prototype to add new properties. And also you can do this with a lot of objects. For example, I can make it like object prototype, let's say print and equal function console log and now I can make it like this. I can create var ob which equals some object, and now I can ob print hello, and as you see here, my hello. Simple, yeah. Even if I make, well, let's make it number or string. I can make it string. Results the same. I can make it number. Results the same. So even, let's say true, results the same. So if I add some new values to this object prototype, it will actually add to all objects. Any object will be using this method. And of course you can ask me about how does it work with primitives. Well, primitives automatically created objects like this, and that's why it also has this method print. Okay, let's go further let's talk about constructors. Let's say console log and create some string, and it has constructor and it equals string. Yes, true. As you see, our all strings, they all have constructor, and this constructor is string. Same about, let's create some number, var n equal 5, and constructor is number. As you see, it's true. Let's try couple more, like true, constructor is boolean. Let's try new date, constructor of course is date, and Toyota constructor is car. And also I wanted to show you like this. And okay, well, actually constructor is car. There is a problem that we rewrited it like this, and yeah, if I delete, it will say true. So constructor of Toyota is object, as you see. Yeah. So when I delete it, you can see, yes, this is could be a little bit confusing, but object is constructor of of our Toyota too. So that's why we can well, I show you a little bit later how to inherit this objects, and you will see that we usually need to set that constructor is car, like this. Oops. Yeah, now as you see, constructor is car, not object. So we usually need to set constructor like this, and later when we inherit something, I will show you that when inherit we also should do this. Okay, but let's go further. Let's go a little bit further, and I want to show you next scene about duck typing. Duck typing. So sometime when you create, you have some variable, and it comes for you from somewhere. You don't know who sent it to you. Some other developer sent it, and you are not sure is it car or not. And of course you can check it with instance of. But in real life it's not always the case, because sometimes it could be you can communicate between two tabs in your browser, and it not always works. Well, it's a small amount of cases when an instance of doesn't work, but sometime. And in this case, developer using JavaScript developers using duck typing, and I'm going to show you what duck typing is. Duck typing is we say if some object can quack like a duck, we can say that this is a duck. And say we can say about car, is this object can run and stop, we can say yes, this is car, because if it have behavior that we expect, so if it has behavior that we expect, we can say yeah, this is object that we expect, and this is called duck typing. So sometimes we need to check if some object has a specific behavior. Usually if you will hear about duck typing, you can say that this is just checking if object has specific behavior, specific functions. And usually we do it like this: console log Toyota 2 type of Toyota 2 and so yes, it's true. So this is this object can run. So that's why we usually consider that this is a car, because it can run. Of course, also we can check if this object can stop, and if it can run and stop, we can say yes, this is car, it can run as car, and we consider it as a car. So if somebody would ask you about duck typing, or you need to use it somewhere, you can say just checking if our duck can quack, then it's duck. If our can run, then it's a car. And just checking if object can do something, it's duck typing. And now we are going talk about encapsulation in object-oriented programming. So let's make our car. Just a second, we don't need it. Okay, our car, it has some engine, but also it's called constructor because I can construct it. So I can make it like this: engine, and here I can send some data like this. Work the same way, and now my car has engine 3, but I created it through constructor and I set data there. Why do I need this? Well, usually this is a class, and class just describe the object, and we can create different objects. We can create car with engine of 2, engine 3, engine 5, and something like this, with different colors like red, green, and etc. So this is the main purpose of constructor. When they construct, they usually construct it from some information. We can create different object, and this is really cool. So if I write console log Toyota 2 engine, we will have 3, as you see. But the problem that I don't usually should use this variable directly. As I told you some time ago, that it's very bad to use it, because for example some people can use your variable and tomorrow you decided to rename it, and you will broke code of a lot of people. So that's why we use encapsulation, and we never directly use any any object variables. For this we use getters and setters or any other method. So to make this variable private and nobody would see it, and we will work with it through getters and setters, we should remove this. Here we can use value, and we can add some getters and setters like this. This get engine equal function which return engine. And this set engine, well, I already told you about getters and setters some time ago. Here we are. So our engine is 3, but if we try to make it like this, we will have undefined, because we don't see it. Now its variable is private, you can't see it. And if we try to make it like Toyota, okay, let's get engine, and now it's 3, and of course I can set it set engine, let's say 2.0, and here we have 2. So that's the way how we usually work with fields with inner variables. Well, this is called a field of object car. Yeah. And we can manipulate it through getters and setters. It's more safely, because tomorrow you can rename this engine to anything you want. So you can do whatever you want. You can return whatever you want. It's just your guarantee to people who use your class that you have some get engine and set engine, and they return and setting something. Yeah, and people who use it, they just call some method. You can return whatever you want, so they don't know how it's how it's make it inside. But they believe you that you can write everything correct. And the cool thing, if people using your code and tomorrow you will find out that you have a bug, you can fix it and no one would not know about it. Or if people already know about it and told you, yeah, you can fix it and no one should change their code. Okay. So this is encapsulation, and now we are going to talk about inheritance with these classes and objects. Okay, as you remember, we can inherit object like this, like sub object equal object create, and we inherit it like this, like some object which has a5, and we inherit. Sub object will be child of this parent object. Cool. What about our functions? How can we inherit our functions? Okay, let's make it like this. We want to inherit our functions, and we should we need to do it like this. We need to create function which would be sub functions from our car. It can do some work, but we will just console log sub. And to inherit something in this object sub, we should do it like this: sub prototype equal car prototype, and we almost inherit it, but also we need to inherit constructor, cause let's consider console log sub prototype. Well, of course prototype is equal. Let's see its constructor, and well, it's better like this way. Just a second. Well, as you see, we don't have constructor, so we need to set it. My constructor set sub. No. This is my mistake. I write prototype here the wrong way, and if you console log like this, this constructor, it's constructor of car, and this is wrong. So that's why when you inherit objects, you need to inherit prototype and inherit construct and override constructor like this. Okay, this object how to show you this. Okay, let's compare it to equal car, and it's true because constructor of sub is parent, so it's car. So that's why we need to override it like this. And now constructor will be sub, and now we can use it just like a car. So I can create new car and, for example, run, and I can create sub and call run. As you see, it's work. Why it's work? Actually it works because we inherited. So the main idea here, what I wanted to show you, so to inherit from one function to another, like we inherited before with usual objects, we just need to inherit prototype and override constructor. So this way we will inherit our objects, which is constructors, which has which is functions and which is constructors. So that's the way how to inherit these functions. Yeah. Also now we have new constructor, and let's make it like this: console log car con and here is sub con. And as you see, well, let's make it like this. As you see, I run constructor and then I run this method. So now I want to run parent constructor from sub. I can make it like this. I can write car call and call constructor of my parent if I needed to. Also I can write it whenever I want, like here. It's make it to construct objects. Just a second. I mean, when I call car call, here I can have some values that initialize object, and if my parent constructor initializing and do the most of the job, I can send these values to my parent. So that's the purpose to call parent constructor. Also I can override methods that I have in my parent. So for example, here I can make it like this. I can write this run equal function console log home. And now if I run, I will run how, as you see. So this was overridden. So for example, I can have new sub which run and stop, but run will be new function and stop will be the old function, as you see. Very easy. And also sometime I want to run my parent method from my child method, from overridden method. This is called overridden, and this is how we change our functionality. So we have some functionality here in our parent, and I overrided this functionality in my child, and this is called polymorphism. So polymorphism, if one object can change its behavior It's like polymorphic. So this is polymorphism, when I change behavior and override some function. But what if I, in overrided function, want to use functionality of my parent? I can make it like this. I can write car prototype run call, and that's the way to call parent. So here we have run when I call run. For example, it can make some useful logic that we want to reuse in overrided method. In this situation, we should run this our parent methods like this, and that was inheritance. But also there is also a way to reuse objects. It called composition. Well, we have two kind of relationship between objects. It has a and use a. Is a and has a. Is a when one object is another object. For example, Toyota is a car, and we have also relationship has a. For example, car has radio. So we can reuse some code using these two concepts: inheritance and composition. And to know which one when use, so if one object is another object, like car is like Toyota is an car, we use inheritance. If one object has another object, we use composition. So what is composition? Here we have some sub object, and we don't want to make it sub, we just want to reuse some methods with composition. So we will do it like this. We will create some car here in this function, like this, car equal new car. So we create new object. We can set something here like 3.0, or we can use it from like here and send it there. But we have this object. Also, we can have this car, this method run, and we want to reuse it our parent run. So we can make it like this: car run, and this called composition. Now if I try to create new sub, I will create object with car with 3 engine equals 3. Yes, and now I can run method run. Yeah, as you see, so this is composition. I make car field of my sub object, and I have also method run, and I reuse method run of my parent. It's very useful because, for example, I can add some additional logic like console log dt on logic, yeah, like this. And here's some additional logic before running some methods. I can wrap some methods like this using composition. Okay, let's go further. I want to talk to you about abstract methods. What is abstract method? Abstract method, this is just a description of what should be done. For example, I can create car and I can make, say, it should run and it should stop, but I don't know how should it run and stop. So my child should decide it for me. And for example, I create this car. How to make well, the idea is that I can't create object of this car, only child object will be created, and this class is called abstract classes. So how can I make car abstract? Very easy. I just need to throw new error here. You can't oh, cannot create car, and that's all. Now if someone would try create new car, they will have exception and no one would create it. So car, this is just description of cars, and also they can have abstract methods to create yeah, there was syntax method new car. Yeah, you cannot create car. Also, I can create abstract methods. Abstract methods, this is methods that you can't run, but you know that there should be in our childs. For example, like run. You know that all cars will run, but you know how fast they will run. And we can throw here error 2, like this. You cannot run. So idea for abstract classes like this. I have some class car. I can create it, and it has method run, which I can run, but it has method stop, and all cars will stop, and I already know how they will do it. So I just state this method as it is. And now I need to create like some subclass which will inherit everything, and here I create this function which will be my subclass. Here I can make it like console log sub, and now I need to override this function. Well, I already did it. So, but I can't run my parent. Override then override and run. Okay, so I overrided it, and now I need to inherit it. So, as I told you before, I need to sub prototype equal car prototype, and also I need to make my sub prototype constructor equal to sub. Yeah, that's all. Now we can create new cars. For example, var sub equal new sub, and we create this object. Then we can stop it and run it. Sub stop, and let's say sub run. So yeah, everything works perfectly, and you just need to understand the idea. So this is like abstract classes implemented like this. So this class that you can create, and it has methods that can be run, but you just told that everybody who inherit me should override this method, and all of them should have this method and should be run. And I know already that all cars that will be created, that will be stopped, and I already know how they will stop, so this method I don't change. Well, of course, if I want to, I would change it. Just like I override run, I can override stop, but I don't want to, because I like this logic and it's good for me for now. Okay, let's go a little bit further. I want to talk to you about immutable objects. Immutable object, this is objects which can be changed. So for example, function immutable. I can create this, let's say a equal 5. And the problem would be that this object is immutable. So new im equal var im equal new immutable. And I can say im a equals 6 and cancel log im a will give us 6. It's obvious. But I want to create a property that would be immutable. I can make it like this. Object define property. Well, we already use this method, you know how it works. I already told you about 4 attributes which all fields has, so we can use it like this. This I want to add property b, and it will have next values. Value will be 3, writable will be false, and numerable, well, let's say true, and configurable will be false. And that's all. We create new property. And now if I have this property b, so I can show you like this. It's 3, but I can't change it. So if I write like b equals 6, it will not work because it's not writable. So this is immutable property. We can't change value of it. This is called mutable objects. And what about function? What if I try to write function? Define property. This, let's call function c, and value will be function. Like function cancel log something like this. Yeah, so we define one more function, and we can call it like imc and qq, and this function can be changed. You can't set new value for it. So if I try to make it like this, like c equal like function cancel log a, and then I try to run it, I still have QQ, so I can rewrite it. But what if I want to inherit it? I can write some small class like function subim, here just let's cancel log something like subim, then sub, well, let's call it from the big S, subim, so we inherit it as usual. And now I create var s equal new subim, and cc. Okay. Just a second. So it's told us that C is not a function. So you cannot use it in sub object. But you can override it. So you can write like sub im prototype like C function console log new, and then it will work. Cause so this function C can be inherited but can be overridden, and you should know that. Yeah. So to create a mutable object, you can use these defined properties, and they will create immutable object. Okay, let's move further. Let's delete all this, and I want to talk to you about inheritance. Okay, let's have some car which console log car. It can have some function like run, and we want to inherit it, and we can inherit it using code like this, but there is also another way to do it. We can create object, we can inherit objects through object create, as we did it with our JavaScript usual objects. So we can make it like this, like function sub console log sub and here we can like sub prototype equal object create, and here object that we want to inherit like car prototype, and then we should describe values that we want to override or add new properties. So and also we need to override constructors. So constructor equal, and here looks strange, but we need to set their object, and it object has value, and value will be values that would be new constructor like this, like sub. Same for others. For example, I want to add method stop. It should be also object, and this object has value, and this value will be set to stop. So we can make it like this: function console log stop. Yeah. So we can inherit like this, and now I can write var s equal new sub. As you see, it works, and also I can s run and s stop. As you see, it run and stop. So here I create new method stop, and run was inherited from our parent. So that's the way which you can inherit your functions to your object functions, your classes. Yeah, so here if I had some sub-object which inherit car, I can make it through object create like this. As you see, it's very easy, and sometimes you should use this. Okay, let's go further. Let's say I have, okay, let's delete it. Okay, I have this function car. Cool. But what if you create object car too, and some person want to use our cars in his code? How do well, it would be conflict, because if there is two cars, yeah, it would be conflict, as you see. Well, yeah, I didn't name it. Well, it's not a conflict, but as you see, nothing happened. So it ran this car, not this car, and sometime it could be there could be problems when there is a lot of objects with the same name. So for example, we can create persons, you can create person, I can create person to save information about person, and it could be a problem. Well, it's a problem in any programming language, not just JavaScript. So usually they decided with namespace or models. So you need to put all your classes to specific models and using it through this model. So you need to say, I want to use car from this model. So for example, like developer can't create model, some model, you can say I want to use car from can't model. And there's two ways to create models in JavaScript. I am going to show you them right now. So the first way is use it like this: var model. It's very easy because it's just usual object, as you see. And now you can write like this: model car equal function. And now now my model has object car, and I can create instance of this object. And to create it, I need to use this model. So for example, var I don't know, c equal model, new model car, and now I can see run. Yeah. As you see, it works the same way. So my car now is a part of model, and to create it I need to set, yeah, I want to use car but from this model. And as you see, we just use usual objects like this. And you can have model 1, I can have model 2, so I can name it, for example, as my project or as my product that I created. I can call like jQuery or something like this, and it's how my model will be called if I create some specific library, or JUnit if I create classes for JUnit, and something like this. So it would be my model. And what about the second approach to use models? It's like this: var my model, let's call it 2, equal function. Here I can describe something like, for example, like this value equal 5, this car equal function, this car prototype, let's say get value equal function return value this car prototype set value equal function x value equal x and return this car. And that's the way how you can, oh yeah, forgot the main. So this is anonymous function, as I already told you about anonymous functions, which return car. And this car has value. Well, this use closures. So when we will return this function, it also will have this value as saved somewhere there with this function, and we can use it with methods get value and set value, which we added to this car, and they will set and get this value. It's very easy. And now I can write something like var, let's say car equal new model 2, and there will be a new car. So I can console log car get value and car set value and get it again. Well, as you see here, my new car value from here, and here that I changed. Yeah. Oh yeah. Sorry, as you see, my first value of value was 5, so here we have 5, and then I change it to and now value is but it doesn't matter. The main idea that I use anonymous function, which I told you about, to create model, and this model returns this object car. So now I can use it my cars through this model. So this is a two ways to create models, like usual objects or anonymous functions. Well, that's pretty much it about objects, constructors, functions. That's all for today. Well, thank you for watching and have a nice day. Bye.